Okay, this is an optional worksheet. I have it on Schoology. If you want to print it, you can. Or if you just want to look at it, it's just more practice with z-scores. So if you just want to kind of look through this, question 1, less than 2.16. So we're going to get a big answer, and you can look it up on your sheet. Greater than negative 2.45, notice it's still a big answer, 0.9929. Okay, here's a practice in between. So remember, for these, you want to look up your big number first. That's the 0.8997. And then look up your 0.79 and subtract. Same thing here. So this is, if you are like confused with z-scores, I suggest you guys print this out and practice this. Between 1.5 and 2.5, look those up. Okay, more practice in betweens. So this is question 5.4846. All right, now you're going to have to draw them yourself. Greater than negative 2.56, it's multiple choice. I think they had a number a little bit wrong, but C is really close to the correct answer. Number 7, again, it's in an in-between. So you want to look up, well, I kind of maybe, no, I did it right. I did it the way I taught it. So there's my 2.45 answer, there's my negative 1.76 answer, and when we subtract, you see the answer is close to A. Question 8 is B. Question 9 is C. So lots of practice with normal curves there. Question 10, I kind of shortened this for a class in the past, and we just did 2 and 3. But you can kind of check your answers with that. Okay, here's a working backwards one. So let's do this one together. What is the z value that corresponds with the given area? Okay, can you guys tell by looking at this, we're going to have a negative z-score. The problem is, if you look at the negative z-score side in these areas, we're never going to see a 0.8962 because all of these numbers are smaller than 0.5. So what I did is I found this side first. Like 1 minus that is 0.1038, and I can find that exact thing on here. 0.1038 is right here. So that's a z-score of negative 1.26, and that's the answer. Find the z-score that corresponds to the given area. And maybe since they shaded to the right, it would actually be z is greater than negative 1.26. Okay. Here wants the z-score that corresponds with middle 90%, which would mean 5% off of each side, which would mean this is 95%, like that. And then again, you want to try to find 95%, and it's close to 1.645. I would accept 1.64 or 1.65. So that's kind of a weird question. Okay, and then you actually get to some problems on the back where you're making your own normal curve and putting the mean and standard deviation and answering the questions. So 13, question 1, 0.9803. Question 2, 0.2514. Question 3, 0.3434. Okay, oh, here's a question about a top 10%. So top 10%, do you guys agree that really is the 90th percentile? If you're in the top 10%, you're better than 90%. So we want to look on the positive side for 90%. And right here, we're really, really close, these two. So what did I choose? I chose 1.28 equals x minus 95 divided by 15. And I solved that in my calculator, and I got, 114.2. I chose to round up, but basically either of those answers I would accept. Okay, question 15 is about how much time kids spend on TV. 14 is the mean. Standard deviation is 3, more than 20 hours a week. Okay, now we're talking about 25 kids. 25 kids in the playgroup, that's your N. So what we need to do is we need to make a new skinnier normal curve. 14 is still in the middle, and now our standard deviation is 0.6. I did not show my work. Standard deviation is 3 divided by radical 25, and that's where I got my 0.6. I got a crazy huge z-score of 10, which is greater than 10. That's like off the charts, is basically 0%. Remember we talked about the other day, the squiggly lines means almost 0%. And finally, question 16 asks you about one egg and then a dozen eggs. So for one egg, you use the regular mean of 215 and the standard deviation of 15. And what's the probability the cholesterol is going to be less than 210? I forgot to shade. So you just find your z-score, and I got 37.07%. Now I'm talking about a dozen eggs. What's the chance that their average is 217 or less? Okay, so I had to first change my standard deviation. I had to do my 15 divided by radical 12, and that's your new standard deviation. And this is the average of your 12 eggs. Okay, so the 215 is still in the middle, but now it said less than 217. See how that's a lot of the normal curve? I got a z-score of 0.46 and a final answer of 67.72%.